specific heat and heat capacity. What's the specific heat? Energy required to do what?
gram.
To raise what? The temperature, the T, what? Of 1 gram of substance by what?
1 degree in Celsius.
1 degree Celsius. Okay, how about heat capacity? Energy required. Yes, help me to write.
To raise the temperature.
Temperature by 1 Celsius degree.
1 degree C. I did not mention what?
The mass.
The mass is not mentioned. That's the difference between C and S. So what's C if we know the heat and the specific heat? C is actually equal to M times S. Clear? C is mass times S, which is specific heat, and it will be all by the unit will be degree C. That's important. Now, I want you to know that Q is very important. Q is equal to what? Very important law you have to know and know very well. Q, which is the heat, is equal to what? What's S?
Specific heat.
Specific heat.
M?
Mass.
Mass.
What's delta T?
Change in temperature.
Temperature.
Good. Okay, how about if we have heat capacity? What's Q? Yes,
Heat.
heat. What's C?
Capacity.
Heat
Heat
capacity.
capacity, delta T is change in temperature. So what's the relation between C, S, M?
Are equal.
Can you see this? Okay. Memorize these two equations. Very good. Next, this is the specific heat. As I said, I don't want you to memorize any of these numbers. Nothing. There is one which is water. It's available in what? In the periodic table. So don't memorize it, but keep it in mind. But the number is available in water. Okay. What's the specific heat of water?
4.184.
0.184 joule. What's the unit? Joule per what?
Per gram Celsius.
Exactly. Also, the specific heat of water is of H2O is equal to 1 calorie per gram degree C. So what's the specific heat of water in calorie?
One calorie per
One.
gram.
That's why I want you to know that 1 calorie is equal to what?
4.184 joule.
184 joule.
Exactly. You have to know this. As I said, you don't have to memorize the number, but you can get this number from where?
Periodic table.
Periodic table.
Table and from the heat, the specific heat of water. Is this clear?
Doctor,
Yes.
don't we use Kelvin as a unit of temperature?
No.
In this case?
In this case, you use delta C, degree C. But let me ask you a question. Delta T, if we have delta T.
That doesn't matter, the units between Celsius and Kelvin.
So if you have the two temperatures, if you are dealing with delta T, it doesn't matter if it's Kelvin or degree C. Is this clear?
Yes, it is. Thanks.
Calculate the amount of heat required to heat 255 grams of water from 25 to 90.5. So what's delta T?
90.5 minus 25.2.
And this is must be multiplied by what?
4.184.
Give me the answer.
Should the mass be in kilogram?
Good question. Should the mass be gram or kilogram?
Gram. Because
Why?
the unit is gram.
Yes. Look at the unit for specific heat. What is it?
A gram.
Gram. So the answer is per gram. And the difference in degree C. Can we have the temperature in Fahrenheit, for example?
No.
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 Why? Because it's different. This is per gram degree C. That's the point. Okay, what's the answer?
69669.
9 by 0.66.
9.66.
67.
Very good. That's it. All right.
Doctor?
Next. Yes.
But he needs kilojoule, isn't it?
No.
It's kilogram.
Okay. Yeah. Oh, okay.
So we multiply it by.
This is times 10 to the power 3, because I wrote it 69 already. Joule or 69.7 kilojoule. Doesn't matter. That's easy. I hope
Doctor,
so.
what is S
This where?
in the equation?
Oh
Q
my.
equals S.
You should tell me, what is it? What's this?
Specific heat.
Did you memorize this equation?
Yes, okay.
Okay, this is S is specific heat. Okay, good. Okay, next. This is called cup calorimeter. Don't forget it's cup. This is cup, you know, the cup that we use for coffee. That's why they call this one cup calorimeter. Okay. Why did we call it cup? Because it's a cup, right? When we say meter, what's this? Means measurement. All right. What's calorie means? So this cup is used to measure heat. That's why it's called cup calorimeter. Okay. In this case, our system is the liquid inside, which is the water. And anything outside is what? Sorry. Okay. No. I will say that. Our system here is the chemical reaction. System is the chemical reaction. So this is the system. In this case, the most important surrounding, everything is surrounding, but the most important surrounding is what? The surrounding is the what?
Cup. Water.
The water. The water. All right. So when we measure the heat of the water, what does that mean? We measure the heat of what?
The surrounding.
Okay. And if I want the heat of the reaction, what should I do with it?
Multiply by -1.
Exactly. That's why this is very important. Don't forget that we're going to measure the heat of the surrounding. The Q that we're going to measure is for the surrounding, which is S times M times delta T, and then the Q of the system equal to minus Q surrounding.
Doctor, could you please repeat it again?
Again, always in the cup calorimeter, where is our system? Is the
reaction.
Chemical reaction. Clear?
Clear.
So, where is our surrounding? The surrounding, everything around it. The most important thing, the only thing which is really important is what? The water.
Water.
Only. The rest, the air and everything will get some heat, but most of the heat, all the heat almost will go to the water. And that's why this is the heat of the surrounding, which is the water. What we measure is the heat of the surrounding. So when we measure the heat of the surrounding, if I want to measure the heat of the system, it is equal to minus Q of the surrounding. And so when I give you a problem to solve, you're going to calculate Q for the surrounding and tell me what is the heat of the system from that reaction. Let's do this problem, and I'll get back to this one to explain it even more. A metal pellet with a mass of 100 grams. So we have, this is the cup. We have a billet. What's billet means? What's the meaning of billet?
صفيحة.
قطعة metal, قطعة metal of 100 grams, originally at 88.4. Okay, is dropped into 125 grams of water, originally at 25.1 gram. So degree C. So we have water here. What's the temperature of the water?
25.1.
What's the temperature of the billet?
88.4.
88.4. Very good. We know the mass of the billet is what?
100
100 gram.
Okay. What's the mass of the water?
125.
125 grams. What's the specific heat of water, which you should memorize, but you just don't have to memorize, but I think everybody knows it now.
4.184.
Now let me ask you a question. If we have this billet with 88.4, am I recording, by the way? Okay. Okay. If the billet is was 88.4 degrees C and the water was 25.1, when you drop the billet here, what will happen to the temperature of the water? Increase. What will happen to the temperature of the billet? Decrease. What, until you reach what? Equilibrium. Both of them will have the same
equivalent
final temperature. The final temperature was 31.3. So what's the, where is your system now?
The water.
The system.
The reaction.
No, there's no reaction this time. The billet. Okay, what is the surrounding?
Water.
What's the Q of the surrounding, which is the water? Do we know?
We can multiply them.
Yes, SMT.
Which is what? 4.184 times what?
Times 125.
Okay, times
25.1.
No, wrong.
31.3.
No, wrong.
The difference between them.
31.3 minus 25.1. Clear? Give me an answer.
3242.6.
324.6. Good. What's the Q of system?
2.6.
2,
3242.6.
2.6. Right?
Yes.
Okay. 3242.6. Good. What's the unit?
Joule.
Joule. Okay. What's the Q of system?
Negative
-1.426.
surround.
What? Minus
3242.6.
324.6. Exactly. Okay. Which is actually equal to what? It's the
Negative
negative.
the surrounding heat.
Exactly. What's this equal to now?
C delta T.
Times what? Times what?
Hundred.
The mass.
100 times what?
Delta T.
What's delta?
Times 57.1.
No, don't tell me just 57.1. It's actually
88.4 minus 30.
what? Yes. No,
1.
just a second. It's not 88.4 minus 31.3. Wrong. It's 31.3 minus 88.4. Why?
The final minus the initial.
Yes, yes.
Exactly. This is the final temperature. This is T final for both of them. And this is T initial. That's why it is like this. So calculate S to me now. Give me what's the value of S.
Minus 155,000.
0.567.
567.
0.567.
Doctor, didn't he say the capacity?
Did he say capacity or specific heat? I don't know. Okay, calculate the heat capacity. Oh, okay.
Yes, multiply by 100.
Yes,
100, yeah,
this is
yeah.
a specific heat. What's the heat capacity? Very good. We can do it also. Yes, good. Thank you for reminding me about this. What's the heat capacity?
56.7.
And 79.
56.7. Clear? How easy?
Very.
Easy.
57, exactly. So yes, 56.7 or 57 is the C of the billet. Now, I want you to know, don't memorize anything in this table except what are we doing? What are we doing in this reaction?
Neutralization.
Why we call it neutralization? Because it's
Between
what?
base and acid.
From base and acid, and this is delta H for this reaction. Don't memorize it, but I want you to know, I can give you, I tell you, the heat of neutralization of HCl plus and NOH is this number. I want you to be able to write the reaction. What's this called? What are we doing here?
Decomposition.
Ionization.
Ionization. We're making ions from molecular compound. Ion from molecular compound. What are we doing here?
Melting.
Melting or fusion. Same thing, yes. Heat of melting or heat of fusing. I agree 100%. Very good. What are we doing here?
Evaporation.
Heat of vaporization. So I can give you only the name. If I tell you what's the heat or the heat of condensation of water is X. Then can you write equation? Can you write equation for me? I said condensation. What does that mean?
From
Negative.
gas to
From
liquid.
gas to
Exactly, from H2O gas to H2O liquid. And what's delta H?
minus 44.
X.
Exactly, in this case it's X, but actually, yes, excellent view. It is actually minus 44 degrees. Clear, kilojoule. Why did I write minus?
Because you flipped the equation.
Because we reverse the reaction. We reverse the reaction. Very good. Next, the second calorimeter is called constant volume calorimeter, or this is called bomb calorimeter. Bomb calorimeter. What's bomb? What's the meaning of bomb?
قنبلة.
بالضبط. بالضبط. That's the meaning.
شعر انفجاري.
This is the bomb calorimeter. We put the compound inside, and usually we burn it, and that's why it's not in water. Usually we take the compound and burn it inside, and there will be reaction. And when we have the reaction, we can measure it. We can measure the amount by where is the surrounding now? Where is our system?
The reaction.
No, it's not reaction. There is only
calorimeter.
the compound. Maybe it's a reaction, maybe it's anything inside, but usually it's not reaction, it's burning usually. Combustion reaction. Usually we burn it with oxygen or something like that. All right, and where is our surrounding?
The water.
Calorimeter.
Everything around it. It could be, Q in this case, I can give you a specific heat of the whole system, and so the Q of surrounding, in this case, it will be C times delta T. But also I can tell you that there is amount of water in it, and I will give you the Q for water by itself and for the system by itself also. So it will be delta C for the system plus ms delta T for the water. So it depends on the question. If the question tell you that the C is for the whole calorimeter, then you should calculate it for the whole calorimeter, including the water. If I tell you no, this C is for the calorimeter without the water, and the water is by itself, you can do it. You have to have the Q for surrounding for both of them. Is this clear? Okay, good.
Doctor, in the second case, we add them, right?
In the second case, yes, we add them, of course. Yes, of course, we add them. C delta T plus ms delta delta T. What did I write? Delta H, delta T.
So,
yes.
I didn't get the point from this equation. Why we do this?
يعني الآن it's possible that he give you C of calorimeter. All right, in this case only, and he did not give you any other information. Okay, what will be Q in this case? Q of surrounding in this case equal to what? C delta T. Clear? Next, if I say you have C of calorimeter and there is 200 grams of water inside. Then what's Q? C of calorimeter times delta T plus what? 200 times
Plus 200 gram.
4 plus times delta T. Is this clear? In this case, I gave you the mass of the water, so you have to do it by itself. If I don't give you any mass or anything, just use this equation.
The water is surrounding the doctor, right?
It is all surrounding. It's all surrounding. The Q that we're doing is the surrounding.
What's the
How I
system?
can get temperature?
It will be given to you. The system is your reaction, I mean the compound. This is the system, the sample only. Clear?
What's the difference between this?
I cannot hear you.
Why we do that? What's the difference between these two cases?
لما أعطيك وزن الماء, when I give you the mass of the water, you have to find delta H for the water, Q for water, and Q for calorimeter, and add them together. If I don't give you the mass of the water, then do it for just the surrounding, for as if it is calorimeter. This is including, in this case, the water.
Okay. Thank you.
Good. Next, let's solve this problem. We have in the bulb calorimeter, in this case, we have chocolate chip. أخذنا بسكوت, chocolate chip cookie. The mass is 7.25 gram. Is burned. We burn it in our calorimeter to determine the energy constant. The heat capacity of the calorimeter is 39.97 kilojoule per degree C. During combustion, the temperature of the water in the calorimeter increased by 3.90 degrees C. Calculate the energy content of the cookie per gram. I want it in kilojoule per gram. All right. How much did I burn?
7.25.
So when I finish, I must divide the answer by what? To make it per gram. Divide by this number. Clear? Okay, now which one we're going to use? This equation or this equation?
First.
Why first? Yes?
Because we didn't have the mass. Because he didn't give the mass of water.
Exactly. He did not give the mass of the water. So in this case, what's delta Q? I mean Q. What is Q of the surrounding equal to?
It's including water.
Okay. Give me, what should I write? C delta T. What's C?
39.97
Times
3.9.
Why? What's delta? What's minus what?
This is the difference, 3.9.
The difference, because it says here increased by. So whatever you start with, you end up with delta T equal to 3.9 exactly. So give me an answer quickly.
21.5.
21.5 kilojoule. All right.
I divided by the grams.
No. You are going ahead of us. Don't. That's why it's wrong.
It will be
So this answer in joule, not kilo.
155.
Just a second. Okay, just a second. Now I still want this answer. Multiply 39.97 times 3.9.
155.88.
Okay, give me one by one number. 4.
155.9.
No, say it this way. Don't tell me 155. Tell me 155.
4 15 point
15.
0.88.
155.88?
Yes.
Is this the
Yes.
answer? Okay.
Yes.
Now, this is, as you said, this is the heat of the system, of the surrounding. What's the heat of the system?
Doctor, this heat in joule, not kilojoule.
No, it's already in kilojoule.
No, you should divide by. Okay. Thank you.
No, it's already in kilojoule because this unit is kilojoule already. So what's the Q of the system?
Negative 155.
Exactly. So what's the per gram? What's the heat per gram?
Divide 1.5.
Divide by 7.25. Give me answer.
To 1.5.
1.5. All right.
Negative.
Now I want to know, should we put the negative or not?
Yes.
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 Actually, if I want to put it as delta H, then I should put the negative. But if I just tell you what's the heat capacity, you don't have to tell me it's minus 21.5. It is 21.5. You don't have to put the minus. Clear? Why? Because you're telling me that the heat will be 21.5. And you should keep in mind that because it is exothermic, it should be minus that. So Q is 21.5 because that's the amount of heat. Now, if I want to deal with it in the reaction, then I should put the minus because it's exothermic, because the temperature of the system increased. The heat was given. So the solution is correct, 21.5. Next, His law. Very important law. I want you to know it and know it very well. It's called His law. What's the meaning of His law? If you have many reactions, like these reactions, okay, look at these three reactions. Okay, reaction 1, reaction 2, reaction 3. We have three reactions, and this is the heat of reaction 1, reaction 2, reaction 3. I want you to look carefully. Anything that is available in the reactant and the product cancel with each other. Look here, the O3, how many O3 do we have? 1 O3 in reactant, 1 O3 in what?
In the product.
Product. So what will happen?
Cancel each other.
Cancel each other. Okay, look at NO is kept as is. Look at 3/2. In reactant, you have 3/2 O2. What do you have in product?
O2 and half O2.
Half O2.
This is 1, and this is what?
Half.
Half.
What will happen if we have 1 and half?
3/2.
3/2.
So they will cancel each other. Now, whatever is left, put it down. You put it down like this, NO plus O to give you NO2. Then you add this heat and you'll get the final answer. This is done by Hess. And this is the way we do things.
No,
How easy?
I think he get to O3 minus O2. It will be O1.
ايش
في البداية كان مكتوب O3 وفي الناتج O2. يعني لو نقصناها تصير O1.
لا 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 ما له علاقة بالون. We are not dealing with the oxygens. No. We're dealing with a compound. الأوزون هنا. This is ozone. there was one, we cancel it with this one, regardless of the other things. And the oxygen O2 here, 3/2, and we have here 1 here and half here. We add them together to make them cancel with each other. Now, NO is left, not cancelled, so we put it as it is. O is left, we put it down as it is. NO2 is left, we put it down as it is. Now, ايش المطلوب منكم؟ انا بعطيكم المعادلات بالصورة هذه، والآن أبغاكم تستخدمون المعادلات الثلاث هذول وتسوون الحرارة حق التفاعل هذا. كيف حتسوونه؟ أول تفاعل حخليه زي ما هو. أوكي؟ فعشان كذا الحرارة the heat will be minus 198.9. Now, the second one, how can I make the ozone in the other side?
Reverse it and make it
reverse it. Why am I going to reverse it? I want 3/2 O2 goes to O3. What will be delta H in this case?
Positive.
Positive.
142.3. Why did I do this? Because I want to cancel the ozone with the ozone. Is this clear?
Doctor, could you please repeat it one time?
Okay. الآن I kept the first. الحين هو احنا نسوي الحل اللي سويناه هنا. احنا نبغى نوصل للتفاعل هذا. ولكن أنا ما أعطيتكم التفاعلات زي ما هي كذا. أعطيتكم إياها بالصورة هذه. What we are doing, we kept the first reaction as it is, and that's why delta H for this reaction is minus 198.9. This one, I reverse the reaction. 3/2 O2 goes to O3. What's the heat? 142.3. Why did I do this? I want to cancel the O3 with the O3 is cancelled now. Clear? Now, yes. Last thing. How many O do I need? Only one. How many O do I have here?
2.
2. So how can I make it 1?
Divide the equation by 2.
Okay. What's the other question is, where is the reactant? Is this reactant or product? In here, is it reactant or product?
Reactant.
Reactant.
What's here?
Product.
Product. How? I want it as a reactant. What should I do?
Inverse.
Reverse.
Reaction and divide it by 2, half O2. What will be delta H in this case?
Negative 495/2.
Exactly, over 2. Now, what will happen? The O2 here, 3/2 O2, will cancel with what?
With O2 and half O2.
Okay, what will be the delta H for this reaction? Now you add the numbers that you wrote here. Add them together. Do it for me. Add this number plus this number plus this number. Give me an answer.
Minus 304.1.
304.1.
304.1. Is this clear? That's how we do. That's how we do Hess law. Yes.
الدكتور
الرياكشن اللي تحته NO plus O هذه it's given in the question.
هو هذا المطلوب to find delta H for this reaction.
So it will be given in the question.
No, it's not given. I want you to find this one. What's given to you is this one, and this one. You should play with the reaction so that you get to this reaction and you get this answer. So this is what's required to find this number. Clear? And this is yours. You're correct. Yes.
There is only one compound I can solve it, so like oxygen.
What? Repeat.
There is only one compound I can solution, like in the question, like oxygen.
Yeah. Yeah, it will be there. It will be left. يعني ال NO هنا did not do anything to it. It was kept as it is. ال NO2 also, nothing happened to it. It was kept as is. Right? The O is also not used, and so it is not used. But whatever is available in reactant in one thing and even product in other reactions, you cancel it with each other. That's the whole thing. Okay, with this, we finish the lecture today. Still tomorrow, I'm going to continue with this chapter. I did not finish it. So let's leave here and open the